I made this video for 6 years ago, and it's 60,000 views, pretty much, for a programming video, I think. But the problem is I didn't explain the code very well. So I would like to do that now with this here new video. As I said, it's 6 years ago since I made this code, so I have been looking at the code and I couldn't understand it very well, so I had to clean it up and make it simpler. It's because it was an experiment. One of the experiment I did was I tilt the coordinate system. I have removed that. That was too complicated, and I cleaned it up. So let's look at the code. So what's the first thing that happens? Well, you have the starting here. Create the coordinate system. This method is called at the start. Okay, so what's happening here? I made some pictures, so I'll explain it a little bit better. Let's look at the first picture here. So it's a little bit strange. I have the starting point is 300 and 300, so that's that here in the middle here. Okay. So, and then I have x-axis, y-axis, and z-axis, which are these points up here. That y-axis, z-axis, and x-axis. Okay. So that's simple. Why do I do that? Well, I want the steps. I'm interested in the steps. So the way I find the steps is pretty strange. I take the x-axis minus the start axis and divide it by the length between the points. Then I find a step, and y, x. So y, x, it will be 0, because we're just going up, you see? So y-axis, the x is not going to change because x is that way. So it's 0 all the way. And the y in the y-axis is -6. So we go -6 up. And the z-axis, which is that one, the x is minus. You can see it go down that way. You can see it's -4 that way. And +2. So it goes, y-axis is down 2. So it's 4, 2. And the x is this one. The x is going that way, so it's +5, and down is 2. So it's the same down as the z. Okay, so now we know that a step has this values. Okay. Why have I done this like this? I think it's because I had the tilting, the tilt. So I don't remember why I did it like this. No. So now we know what an individual point is. So now we add points, the z-axis and y-axis and x points, and we have a step here, and we just put new x and step y. And how many points do we have? I don't remember. It says something. Maybe it's 30 points. So we have 30 points. So maybe we are having points that are further out here, because we just use this to get 1 point. And you can also calculate that there is the same length between every point. That's not optimal, because they should be closer together in here. So you can make some small changes here to fix that. Okay? So that was the first part of the code here. So now we have the coordinate system here. It's working. So now let's see when we paint it. Okay, so now if we activate something like that, show old cube. So we have two cubes. The old cube is the first experiment, and the new cube is the second. So if I change there and take the method here, we can see that it paint now. So almost everything is calling the paint method. Let's see the paint method. So now, like that. So you can see we draw the gitter here. Okay, so I have inserted this code so we can see what is drawn here if we debug through it. Okay, let's try that. Okay, let's see. We are going to draw the coordinate system. So what's happening here? Well, we have the y points which we are using here, and so you know that those points are going upwards. Y up 1, 2, 3, 4, 5, 6, 7, but we are drawing that one at that one. So that means that we take the y up, and so we take the calculate y set point and y x point. What point are we taking? We're actually taking the last number of point minus 1. Okay, so we're taking the last point here and there, and then draw. I will explain this calculate y set point a little bit later. So let's see what's going on here. So I just continue, and that's the first time, the second time, third. Okay, so this is the y axis which we are drawing all the way. At some point we are finished, and then we can try to take this one. And then go. Then we work with that one, you see. And when that is finished, we will take the last one, which is here. So that's it. Now we draw. Now we are finished with the coordinate system. Okay, so as we saw, we call this method calculate y set, calculate y x, and calculate. We use those two. Okay, there is also x set and x. So let's see what that means. Here, why do we need that? Yes, I made this drawing here. So we need, as you know, we only know the points on the line here, and that one and that one. Okay, so we know that line, all the small steps here, but we're not interested in that. We are interested in this point, which is 6,6. So 6 on the y-axis and 6 in the x-axis. We need that. Okay, so that's what we do here. So I just do some check here just to be sure that I'm not going out of bounds. But then we use this x points x. So we are talking about the x point. So we are talking y x here. So we use x points. So that is this one. Okay, and we take the x of that, which is this green one here. Okay, and the x in that is 306. Okay, so this is pretty complicated. So we want, let's say, the x-axis here. So the x-axis is this one, okay, and x point x, which is this green one here. Okay, it will give us, what is the point? This is x is 313. 30. So 330 minus start x is 300 minus y points y, which is y points y x is also 300. So actually we don't need this one, because the x-axis is always going to be the x of this one, because it's right up down here, you see? So that's pretty simple. I don't know why I have inserted this is always going to be 0. So actually we can just remove that. Maybe it's something with the coordinate system, which was changing all the time. So the x is going to be this x here, which is 330. But the y is difficult. So we take the x points x, so the x point x, which is that, which is now y, x point y, which is downward, which is 312 here. So we are 312 down, but we don't want to be all right here, we want to be there. So we have a problem here. So this one is 312, but we have that wall also, which is the y-axis. So we have to move it up, because from this distance here have to be moving up here. So we say y point y, which is this one, is 300 minus start. Why is it y? No, it's 200 here. Sorry, 264 minus 300, and then we get this y is 276. So this one is a little bit complicated to calculate here, but we have to remove it by this distance here. This distance from this one to this one, we have to take that one, we know that one, and go down the distance of these two down, you see? Then we end here. So that's why now we have a function that can make, when you can add 2, 6,6 in the y-x-axis, and you get a new point here. Okay, that's important, because at the later stage we want another point, this one, which is 6,6,6, which is I think it's this one. Yes, that's this one. So I break it up into 3 functions. I get y x, x set, and set y. So now we can get from 3D to 2D. It's also very complicated. So we know the x, calculate x set point. So x set point is this one. Okay, x set is 306, 3,204, and we have the other point, which is yx. So yx. So we are using that plane and that plane. We don't need this plane. We could have taken this plane or that plane, but we just selected 2 planes. That's enough. So we get this one. Okay. So what do we know? We know that the x-axis is easy. That's just this area here. This is 306. So there's no problem there. We know at this one, this point is in the x-axis 306. So that's no problem. As we get here, 306 minus this 0. Huh? You see, this is just going to be 0. But this one is a little bit difficult. Because we have to take, we know this point, and this point is this point moved to that point, you see? So you have to stand here in the red and move exactly the same as we do here. from this point to this point. So that's what we are calculating, and that gives us an x is 306 and y is 288. So now we have what we want. We now know what is the 2D coordinate if you give it a 3D coordinate, x, y, and z. So this is very important. This is the basic of the system. Okay, so now we have the coordinate system, and we can also get every point in the 3D area here. So now I can add a cube here. It's pretty simple, and I can just move it up. You see, it's discrete steps, and x-axis and z-axis. Okay. So that's pretty easy. Let's look at how the code looks for that cube. So when I activate the checkbox, you can see there's I create a new old cube here, and then I paint it. So what happens with here? You can see that the cube is just rectangles created, north, south, west, and the size is 3. So they are 3 on all direction. We can just fool around with it and say, let's see, 1. Let's see how small it gets. See, just 1 here. That's not much. Yep. And of course, we just move it by this one. It's just pretty simple. Let's see how it's done. Y, we take the cube and say up Y. Yeah. And we take the rectangles. All rectangles are moved up Y. And for all in list, if Y is smaller than that, just add 1 to it. So that's pretty simple. Okay? So that's the simple part of the system. But now let's look at the complicated part where we have a new cube which we can rotate. So let's look at the new cube. That's this one. And you can also paint the full cube, it's no problem. And then again you can rotate and all that, which you already have seen in the first video. You can make it a little bit bigger also, and rotate and out. Okay. Oh, how are we doing that? Let's look at it. So when we activate that checkbox, we go into this method which creates a new cube. Okay, and that's pretty much the same as the other one. But there is a special thing here we should think about. It's a little bit difficult. Okay, let's first start by looking at the rotation. So every time we rotate all points. 1, 2, 3, 4, 5, 6, 7 points. Why is there not 8 points? That's because we have 1 point that's always at the same place. It's not rotating, it's just fixed. But all the other 7 points have to rotate around. Okay? So we have to rotate all 7 points around the x-axis and all the 7 points on y-axis and z-axis. Okay? And then what are these doing here? They're doing this. So every single point has to rotate in 3 rotations, x, y, z. And what is this? Well, this is taken from Wikipedia. So you can see that in the Wikipedia it says the rotation matrix for x-axis, y-axis, and z-axis, and you have 1, 0, 0, 0, cosinus, sinus, and all that. And you can see that's exactly what we have here. So I have degrees here, and x, y, z double, and we calculate the x, take one time the x, one time here, you see, and plus 0, 0, and this is going to be 0, of course, and 0 as a cosinus, cos, I don't know what's called in English. I never talked about that before. No, cos, but then it's called a cosinus, I don't know, don't remember. Cos times this one and minus sin that. So it's exactly the same as say here. So this is just taken from Wikipedia. So it's not that difficult. Okay, let me explain how the rotation works. So you have seen how we calculate the coordinate system. This is not the coordinate system. We have the coordinate system here. And the new cube, not this is the old cube. The new cube is also inside this coordinate system. Okay, but the rotation is around the set 0.0 plus 0. That's how it's made, so I just use that. Well, why are this cube or this drawn down here? That's because I take the rotation from 0, 0, 0 and move it up. I move it to 10.10 to 10. Move it up, that's this point. And then I make the length of 5 here, you see. So this is 5 length. So you have to imagine that this is all the way here, down here, and this is the length of 1, not 5, okay? Imagine that. And then you can see that the x vector is this one here. It is of the length 1 in the x-axis, that's right. This is 0 and 1 in x direction, that's 1. And this one is, of course, if you imagine it's all the way down here. It's gonna be 0 in the y direction because it's always then y. That way. So 0, and in the z direction, that direction, it's also 0. There's nothing. So it's only 1 in x direction. The z is, of course, 1 in the z direction. The z, and that's the z, and 0 with the other. And y is 1 in the y direction and 0 with the other. Okay? Now, then we move it to point 10, 10, 10, which is this point, and we add 5 to the length. Okay? That's why we are here. Okay, that's okay. So let's rotate it. Okay? Let's rotate it in the x direction. That means that this one is just going to be still, absolutely still. It's not going to move because we're rotating around the x-axis. Let's push this. You see, x is just absolutely still, nothing happening. Okay, let's go home again here. What happens? Well, if you look at the set, okay, which is 1 in z direction and 0 with the other direction. So if you look at this one here, 0, 0, 0, 1. 1 is the z direction. After 90 degrees, the z will be 1 down. So the z should be 0, 1 in y direction. And y direction is the second here. Here, this one. So this should be minus 1 after 90 degrees. Okay, 90 degrees here. You can see minus 1 in the z direction. It's minus 1 in z direction. And if we go 90 degrees more in 180, it should be minus 1 in the z direction. Okay, which is the last one. Let's try that. 2, 3, 4, 5, 6, 7, 8, 9. There. Minus 1 and all others is 0. See, now it's pointing that way. Minus 1 in the z direction. See? And at last it's going to be 1 plus 1 in y direction. Oops, too long. I don't know. There. Yeah, that's. It's 1 in the y direction. That's right. And then we go home again and we are at the same place where we started. So this is the idea. It's not that difficult. So let's take it again, and you can see that's why we move it here. So if I now again take set and point it down to -1 in the y direction again, you can see where is it in the coordinate system. Well, it starts in 10.1010, but this goes down -0.5, so it should be 5 in y direction. So is that the case? Set is going 5 in the y direction. That's right. You see, that's why 10 minus 5 gives us 5. So that's the idea. So now, did we see that everything is clear here? Yes, that's exactly that. So the code, I'm gonna make set a link into the comment section where there's a link to the code. You have to remember that there's a Windows form here. Okay, so you just get the code behind the form. Huh? So you have to, if you have to work, you have to add these things here, of course. What do we have here? We have this is a picture box. That's where a drawing is. And there's a list box, and this is just check field and all that. There's nothing strange here. I have a timer here. It's timer 3 because it's auto rotate. Okay, it should be easy. So you get all the code here. I make a link, give you a link to that. Thank you.